Välkomna. Nu ska vi lyssna på Reactive Experts idag.
Tack för introduktionen och tack för det här möjligheten att prata med flera organisationer och personer inom solbranschen. Det är precis som Anna säger, vår affärsidé är att ta in det man gör i Tyskland. Tyskland upplever vi ligger före oss i Sverige och där har vår kollega Dennis Menzel som kommer att prata, och jag kommer att introducera honom snart, jobbat med besiktning av solcellsanläggningar under ett antal år redan. Och det här är mycket större i Tyskland än vad det är i Sverige ännu. Och där finns då en certifieringsprocess som vi kommer att prata om också. Så då bestämde vi oss för något år sedan att försöka starta upp det här i Sverige, så att vi är 3 personer just nu i vårt bolag Reactive Experts, och vi är ett dotterbolag då till Dennis bolag i Tyskland. Så är lite grann bakgrunden till oss. Ja. Och här är dagens agenda. Jag kommer att prata lite mer om vilka vi är och vad betyder certifieringen. Vad vi är för certifierade i Tyskland. Det kommer min kollega Dennis prata om. Och vi kommer gå igenom på problem och brister som vi har stött på. Och vad vi upplever vad man kan göra för att undvika skador. Sen på slutet kommer vi summera. Och allting är en mix av engelska och svenska, och det är en blandning av engelska och svenska på presentationen också. Så att, ja, hoppas jag att det inte är något större problem. Låt mig då introducera Dennis. Are you on the line?
Yeah, I'm on the line. Thanks.
Oh, yes. Oh, nice screen. I should borrow that. So Dennis is our expert in Germany that we are trying to learn from, and he is also the person that so far has been doing the inspection that we have been doing in Sweden. So Dennis, please introduce yourself.
Yeah, hello everyone from Germany. My name is Dennis. I'm the CEO of Reactive Experts here in Germany, and also the CTO, responsible person in Sweden. According to our HWO, I'm a master electrician here and an advisor and expert for photovoltaic systems certified by TÜV. Additional on this, I'm a so-called publicly appointed and sworn by the Chamber of Commerce here. And I'm acting for judges in court cases, especially only on PV systems, when 2 parties are arguing in front of the court. In my old days, I was CEO of NAPS Germany, and we installed by ourselves here 2,500 systems from a couple of single kilowatt up to several megawatts. And yeah, actually, I'm the CEO of Reactive Experts company since 2013. And I've inspected here more than 1,500 systems of failed or broken PV systems. Yeah, maybe Roger, you can click some more for you.
Och det här är vi andra då. Mikael Hedlund är våran CEO som också har en bakgrund i NAPS inom solcellsbranschen. Inom dessa var han i finansiella världen. Men de senaste 20 åren jobbat med solcellsinstallationer och leveranser. Och vi startade då bolaget 2020. Och själv är jag ganska ny i den här branschen. Jag har en liten brokig bakgrund inom telekom och IT. Och fokuserar mer på säljsidan. Så att IT-system, det känner jag bra till. So let's go further with the certification, TÜV.
Yeah, so the TÜV is in Germany Technischer Überwachungsverein, founded in Germany 150 years ago. And TÜV is one of the world leading standardization company and institute where you can get certificates for high quality products or services worldwide. TÜV is acting as independent consultants and inspecting factories, electrical installations, including especially solar installations, and you can get a trained certification courses at TÜV for whatever in PV system. If it is a consulting company or installation company or products like PV models and so on. And these 2 standards of course, are European and additional international standards, what is needed to get high quality products out of it. As independent consultants and TÜV certified experts, we inspect systems, photovoltaic systems on and off grids in civil installation or military installations. And there we make technical checks, reports, and audits. Our daily job is designing systems, checking the installation, and make special maintenance for failing systems. Or we try to heal some systems, and we have experience with thousands of systems around the world. Even in case you are only some systems with 4 models in Mali, in Africa, or if it is several megawatt systems, ground-mounted solar park systems in Germany or wherever. Our typical clients are system owners, companies, manufacturers, insurance companies, project companies, investors, and also courts or judges in case we need to make our reports for. We do this job since more than 21 years now, and we have day or weekly 3 or 5 more big systems that we checked.
And then we go through the examples on issues and problems that we have occurred, that we have seen during the inspections.
Yeah. So the following pictures you will see now, these are real pictures. So we will start here. Yeah, this is a typical system in Sweden. You know, these buildings with big supermarkets. We have typically flat roofs or very low angled roofs, tilted roofs with 1 or 2, 3 degrees. And we see a lot of problems with the snow load there. The systems we visited, you can see here in the small pictures on the left side, was not designed correct way, and it was crushed down already during the first winter. You can see that the model frames are not proper enough to carry the weights from snow, and also the structure system is bending and crushing. When this will happen during the first snow, you can imagine that the customer and the owner from the system is not very happy, even in case the system is not even in service yet. So there is not 1 kilowatt produced and the system is already crushed down. Another big system in these flat roof systems with these ballasts, you know, they're not drilled to the roofs, they are just standing on top of the surface from the building, and they should stay on the roof just with ballast. With this ballast and the thermal extensions from the aluminium structure system during daytime, nighttime, summertime, wintertime, the systems are slowly slipping down or towards downwards the angle, the tilt from the roof. And it is destroying on the way everything what is there. You can see as a small pipe, for example, the system slipped down within a couple of months, more than 8 centimeters, and destroying the pipes and the surface from the roof. And when the surface or the roof is leaking and it's dropping into the building, you can imagine that the owner or the company who is inside the building is not happy about that when the brand new PV system is destroying the roof. During our visit and checks, we are using always an infrared special drone where we can make high resolution pictures and measurements from the system itself, and also infrared pictures. And then you can see a lot of things you do not expect in the beginning. For example, here, there's just 1 module not connected to the system. So it was forgotten by the installers to connect them. These things, it is very hard to find out just from only from the documentation or the measurements they have done in the beginning. Another special thing is special for me. I go to make special checkings on site when there is a fire case because of PV system. We have a lot of burnt down PV systems because of product failures, installation and designing failures. That is not showing best picture on PV or this green energy. On the left side, you can see a living house that burned down because of installation failure. On the right side, you can see inverters. You have a lot of these connectors. These connectors are handmade on site, and when they are not made in the proper way, they start to burn at some point. When this will happen inside the building, you have an electrical arc. This electrical arc will destroy everything during the daytime. And in the easiest cases, the connector is just burning away. In the worst case, the whole building is burning down. In the end of the day, when you go to inspect these fire cases, you are able to figure out the connector that was not installed in a correct way and what is the reason for. Some other things are these product failures or bad products that are coming from China. On the left picture, you can see this is a special lamp behind the model. You can see here through the back sheet. So there's our EVA in the back sheet and back side of the cells that is already cracking. So the back sheet is not from enough high quality to withstand in enough way the UV radiation, and is cracking. During this cracks, moisture and is coming inside the laminate and destroying with corrosion the monolaminate from inside. On the right side, you can see some air bubbles. That is also some ongoing process because this is broken, failed, bad cracking back sheet. In the front, these cracking back sheets, you can see on the left side the small cracks in the back sheet where the moisture can come inside, start the corrosion from the cell, and then you have an insulation failure from the cell inside where the 1000 volt DC voltages to the frame. On the right side, you can see the inside corrosion of the laminate when the silver boost bars and the cell connectors are starting to change the silver color slowly to black color or green color. Yeah, some other big mistakes were done because of wrong ballasting. On the left side, you can see a big ballast on top of the structure system. We have a flat roof system here with some insulation below the roof hole, and the pressure is going with the aluminum beam into the building, so it is penetrating the surface from the roof. A lot of screws we can detect were not screwed, so they were not tightened. We have some cases where modules were not tightened or screwed and fixed in a correct way right from the beginning, and during the first storm, one single modules were blown away from the roof and flying through the parking area. And this is a big thing, I guess, when there are thousands of screws to fix them, to get the system on the roof, when they are forgot hundreds of them to fix or to try them. One other big issue and failure is the wrong cabling. It is not allowed by the standards and according to the standards that the cabling is laying directly on the surface on the roof. You can see it here on the left side where the connectors and the cables are laying on the roof. Dirt and all these things are scurrying around the cables. What is not good for the quality and for the maintenance, of course. The right side, you can see some thermal abnormalities we can detect with the infrared drone. On the left side, you can see two models. This is a system with model optimizers, or each two models is connected with each optimizer that is failing here. So you can see, I hope you can see it, that the two models on the left side are a little more brighter, so they're a little bit more warmer. And on the right side, you can see two models that are in shortcut or in short circuit, sorry. Another special checking on site is our electroluminescence. We are offering this service to detect broken cells or production failures during nighttime. On the left side, you can see these broken cells damaged by hail or wrong handling. On the right side, you can see a production failure where the part of the cell is cracked off from the cell. I will come, I guess, some slides later how we do that. Of course, we have the animals on the roof, special in countryside. It is needed to inspect system minimum once a year. If some rats or some other animals are on the roof that are biting into the cables and the connectors, it makes sense really to make their special checkings. On the right side, you can see an installation failure. Here was a brand new PV system installed on the roof with a new layer of roof. It's a metal sheet roof with a wooden construction below. And it was blown away during the next storm completely. So the whole roof, including the PV system, was blown away by the wind and fall down in the carport parking space from in the neighborhood. You can imagine what will happen when some cars and people are below. These are typically during the storm time when the PV systems on flat roofs with wrong ballasting are changing their owner when it is flying from one roof to the other roof and is destroying itself, of course, but also the buildings below and the other things around were destroyed. So it is really important to check if we have enough fixing points to the roof or enough ballast according to the standards, that these things are not going to happen at all. Yeah, this is something I guess you will have some, I haven't seen them in Sweden so far, but hail is destroying also the surfaces from the cells. But let's see in the next slide about the electroluminescence. Yeah, the fire cases with storage systems. So you can know them in Sweden also, especially on the island where there's no grid. We have these battery banks and inverters connected to a PV system for off-grid systems when they are not maintained once a year, or some product failures we have, like you can see it here. The wooden houses will start really quickly to burn. And on the right side, you can see a farmer's building that burned down a couple of hours after wrong maintenance, where they destroyed surge protection devices because of wrong measurement units.
And this means our solution, what do we offer? What is our proposal to take away these kind of problems?
Yeah, you can see our special electroluminescence on site. We have a special camera system with a monitoring where we can run through the PV systems during night time. And on the right side, you can see the electroluminescence pictures on site where we can detect broken cells, broken diodes, or open cell connectors inside the modules. For example, you can see it here that 1/3 of one module is black. So 1/3 is not working anymore. You can measure it, of course, with voltages, but with electroluminescence, you can check it very quickly on site. Next picture. With electroluminescence, we detect also the so-called PID problem. It is a potential inducted degradation of the modules. So the modules are losing efficiency and power from time to time because of this PID. You can see it here in the pictures with these, dark cells. So the cells are slowly dying. And with electroluminescence on site, we can check it very easily and cost efficient to give you a report to claim this to the manufacturer or to the installer. Yeah, and with the infrared camera system, the flying drone, we can detect easily also open cell connectors. On the left picture, you can see that whole strings are not connected at all, so they are not working. You can see it on the more brighter ones, so more yellow. And there are some single modules where you can see additional these open cell connectors when 1/3 of the module is not connected correctly. So it is an internal problem from the module that can be detected. On the right pictures, you can see interesting hotspots produced by production problems or product failures, where we can detect, in this case, temperatures with more than 118 degrees. So fire case very close by. And on the picture below, you can see the product failure mistakes right in the beginning or after installation, where the soldering from the cells is in bad quality. You can detect them. Next picture, please. Yeah, the electroluminescence is, for example, here working very easily. We have a power supply, a DC high voltage power supply, where we let a direct current flow through the PV panels during nighttime. And with the camera system, we can check the infrared light that is coming from the cells to see if the cells are working, if they're defect, broken, or whatever. So we make them visible with this technology. So it is not comparable with infrared drone during daytime. This is electroluminescence on site during nighttime. Due to some summer days in Sweden, we are checking the PV systems on site if the power output from the PV panels or from the cells are promised. And we make these IU curve measurements on site. Also, we are making during nighttime some IU curves, so they are so-called dark IU curves. We make them during nighttime with the PV system to check the strings according to the technique, if everything is working correct, if diodes are broken, cells broken, or if there are some other problems. Because during nighttime, we do not have any shadowing, we do not have big temperature differences, and sun is coming and going during daytime. So we make these special checkings during nighttime. And then, of course, in our reports, we can show exactly when they are not okay, when we have 13, 20, or 18% less power than it should be expected.
I continue in English, so Dennis hear what I'm saying as well. So why do we believe that independent inspection is so important? And what we mean with independence is that also that we are not connected to any, supplier or manufacturer or anything. So we are. This is our main thing to do inspections. So that's why we call ourselves independent of anyone else. In Sweden, we have Elsäkerhetsverket that has some regulations according to some standards here that inspections and maintenance shall be on a regular basis. So it's already stated there, and I'm not sure how this is followed, but that this is according to the Swedish standards. And unfortunately, we see that we find 9 out of 10 inspections that we find some problems on. Not all is of course not so serious, but the inspection that we have done in Sweden have shown that some were very, very serious, especially when you come to the electricity part. That was not so well done, and that despite there is a service agreement from the supplier. And we also see that even if there has been an approval and slutbesiktning in Swedish, we found failures and errors even shortly after this kind of approval. And my own conclusion is that normally it looks very good on the electrical part, but not on the installation on the roof. So I would assume that the guys who are doing this end approval is very good on the electrical side, but has not perhaps so good experience on the roof side. But that's my own conclusion. I've been out for a few. And of course, there is quite, if I'm quite new in this industry, so what I'm discovered is that it's very long warranty periods, both on the installation, normally 5 years, what I know, but also for on the products, it's even 20 years, which is incredibly long warranties, and we see that the product. Well, we find a lot of product faults out there on the roofs. So therefore, it's important with the regular inspections, because you also have what Dennis was talking about, the aging of the system. So it's quite obvious that is seen. So yes, 2 minutes. So it's just a summary. We have a lot of experience. We have experience for over 20 years within the company, over 3,000 installed systems, and especially in Germany, hundreds of claims, and Dennis has been in court and explaining installations and trying to figure out the reasons of the failures. So we have a lot of experience together with Dennis there from Germany. And we also have worldwide experience from the installation time, where we have installed system all over the world. And we feel that this is something that is also coming in Sweden. We know that Anna and others are working on how to get inspections in a more formal way. And I think we are a perfect partner to do this. So with that, I thank you for listening, and let's move to the question part.
Tack Roger, and thank you Dennis very much. Go ahead, unmute yourself if you have questions to Dennis in German or in English, or to Roger in Swedish, or just a comment. Do you think we need independent inspections, or can you do the inspections yourself? Comments, questions?
I have a couple of questions. And my name is Daniel Sjödin from SolarEdge. Hi, thank you, Dennis, for this presentation. A couple of questions. We absolutely agree that there is a big need for inspection. We do lots of site visits, and we definitely see lots of problems out in the field. What's your experience from outdoor mounted switches, Dennis? I didn't see any examples of switches in your presentation.
No. Of course, the pictures you have seen in my presentation are just a small summary of them. I can give you so many pictures. You can make videos or cinemas out of it.
I'm sure.
And, info or PV entertainment for a couple of hours. I have seen several cases where these so-called fire switches were installed on the DC side, outside the building or inside the building, quite after the entrance. But you recognize that they fail at the end of the day. So we do not advise to install any fire switches on the DC side. There are not proper products available where you can really trust in. So in the whole hundreds of thousands of systems here in Germany, we do not want to see them right now on the roof. You have more problems in the end of the day with these fire breakers than without.
Interesting. My second question is regarding PID and how common you think it is in northern countries like the Nordics and Germany. Do you see PID?
Yes, we are seeing PID maybe every week. So the problem more or less starts from old products installed and supplied in 2010, 2013. So we have several of megawatts, maybe gigawatts on products in the market that will fail at some point or because of PID. PID is not that easy to explain. So there are some systems where the power losses are maybe a couple of percent, maybe 1 or 2%. But in big systems, the dropping can be maybe 80 or 90% of the power output. So it is very important to recognize as early as possible if your system is suffering from PID or not.
Okay, because I was under the impression, I was told sometimes some years ago that it was more common in warmer countries, but you see that it's happening also here.
Yes, of course. As warmer it is, or as warmer as the countries are, the problem is getting bigger. But also the inverter technology is a big part of it. Yeah.
I have a question from the chat.
Yeah.
From Isaac. Are the fire breakers failing when operated, or do they fail due to non or poor maintenance?
Well,
when operated or due to poor maintenance?
So we have seen that they start to fail during operating. So when they should switch off, they are not able to switch the DC current off in a safe way. So they start to burn during switching off. And we have seen also some fire breakers wrong installed, so in the other way around. So they were just wrong connected, as the installers were not proper trained in installing them.
It's a bit ironic when the fire breaker caught fire.
Yep.
Yeah, it is.
And that's why I know in some Swedish municipalities, they are very reluctant to have fire breakers.
Yeah.
They have very different policy on this.
Yeah. So I would advise to take care for and to check really the fire breakers that should be installed, that they fit correctly to the string design and to the currents and voltages.
I think Isaac did a good thing. You can write more questions in the chat if you don't want to unmute yourself and ask the questions right out.
Yeah. You can also contact us via email when you have some more questions or need for information from me, Mikael, or from Roger. Do not wait, you can contact us. No problem.
Can I ask a question about the infrared?
Yeah.
Drone pictures. If there is whole modules that are warmer than the surrounding modules, can it also be due to that there's another material on the surface, that there's another type of module installed? What I can understand, I'm Andreason, and I'm working with, for among other things, with the infrared on solar PV at Rise in Borås, and at the moment we are thinking more about this infrared drone activities, and I'm looking at a lot of results from that, and I see this, and I have seen it on big systems, but I think it sometimes it can be due to that you have another type of module installed. But have you seen that also?
Yeah, when you have other type of modules installed, what do we mean really with another type of module?
I mean that you have another material on the surface, which means that you have another emissivity, which can also tell that it can be warmer.
No. So when you have another surface, maybe another anti-reflection coating on top of the glass, you do not see them.
You do not see that?
No.
Okay, so when you have this effect, it's always that you have not connected this string.
Yeah, maybe. Yeah, not only connected string.
No, I understand, because I think yeah, then I understand more. Okay. And another thing that I've seen also, that if you have like a lot of bird droppings on the modules, you have another emissivity, and it can both cause hotspots, but it can also cause that it looks like there is a failure on the module.
Yeah. When you have the dirt from for example from the birds on top of the model, you can see it from the picture. It looks a little bit different when there is something on top of the model that is causing this thermal abnormalities compared with a technical thing inside the model. So when it is coming from itself, and when you have two pictures, an infrared picture and on the same time the high resolution picture, the normal picture, you can see it easily. It is dirt, so it is not a technical thing that makes it thermal abnormal.
So that's quite common also. That I think was my comment. Thank you very much.
No problem.
So I'm very happy that we had this webinar and that we could see. I will though have nightmares all weekend from these pictures, and so I don't want to see the pictures again, but I'm very happy that I could listen to this. So thank you very much for taking your time, och tack också till Roger som har synkat ihop det här bra, morgonmötet, och alla ni som kom och var med. Jätteroligt att vi har startat igång. Det kommer fler frukostmöten under vintern och jag finns på mejlen. Ha en härlig helg.
Tack Anna, tack för att
vi
fick vara med. Tack alla.
Tack så mycket.
Hej då.
Bye bye.
Hej då.
Hej då.